also.
All right, we are live. So we have breaking news right now. Tesla just dropped a brand new demo of their Optimus. This is the Gen 2 version of the bot, but it can now do quite a new features. I've got Dr. Scott Walter joining me. He is a two-time robotics founder. We're going to go look at this video, and he's going to break it down piece by piece, what all the new things that Tesla can now do. Let's go ahead and watch this video.
Okay, so we're starting to see the update that we were probably hoping to get at WeRobot of what it's doing in the factory. And there's a lot of clues of what's going on, and that we will do a breakdown of each of these different scenes so we can understand exactly what are the innovations, what are the improvements that's going on, and what the future is going to look like. So we have quite a bit of interesting new data here, like the charging port here, that we're going to talk a little bit about how that is. There was always a mystery and how it's going to work. And a little bit more going on here. Besides just putting the batteries in, it's able to carry the rather heavy tray over to a different location. And there's also some interesting tidbits in there that we're learning. And finally, going upstairs. I've been waiting for this for the longest time. And then, of course, this here is very interesting, interactions with humans and being able to, just with simple body language, understand the intent of the person of what Optimus is supposed to do. So you don't actually need to speak to Optimus. You can just kind of point or indicate what it is you want to do. So there's definitely a lot of little features in there that we can begin to break down.
Okay. First of all, we're going to rewatch this video and break it down. But that last bit there, where the Tesla bot is handing water bottles to people, that was the biggest complaint people had, because they said, well, we were just at the WeRobot event. You and I were physically there. And they were saying that these bots were being teleoperated. The bots actually grabbed, being teleoperated, grabbed items and handed it to me. And I grabbed it. And they go, that's teleoperated. Here you go. You just saw autonomously. It can do it autonomously. The rumor was, or the news reports were, that initially they were going to do it autonomously, but because it was just too short of a time, they decided to be safe. So this whole criticism,
liability reasons. I'm sure they spoke to a couple, attorneys before they went out there, and they probably said, wait a minute, for liability reasons here, you have to have some sort of safety mode. So having not being fully autonomous, as well as the robots were heavily chaperoned. So if anything was kind of going wrong, there were people that knew how to interact.
Only one fell because of the purse hitting it. I'm gonna play it again, but this time as I do it, I'll read out the labels, and then we'll play it again with you explaining each step. Okay. So it says here, Optimus Walk has become more confident. It can now explore unseen spaces autonomously, avoiding people, obstacles, using neural nets running on its computer, all while capturing visual cues specific to its environment. Oh my God, it understands. Multiple bots build a shared understanding of their surroundings, which they can later tap into for navigation. Optimus can locate and navigate to the nearest charging station. Look at this. We'll talk about whether this is wirelessly. It docks itself precisely using its rear camera. Head back to work later on. And both hands are being used, right? Can now pick up significant payloads, 11 kilograms. Carry it around autonomously without overheating. Also now venturing on non-flat terrain, so it can finally walk upstairs beautifully. We've trained its AI to interact with people. It can react to unsafe behaviors. What does that mean? Hand out different items upon request. Wow, look at that. Even the chips. It's crazy. That's crazy. Little bags. These new skills are all learned by a single neural net running in real time on Optimus embedded computer. Whoa, Scott, this is crazy. This is crazy. That's all autonomous. Now, we'll talk about the speed as well. Okay, so how did you want to break this down?
Well, we can go chapter by chapter, and I guess, just start right at the beginning and move ahead from there. I've got something ready here to be able to share, where we can kind of walk through and go frame by frame if we want to take a look. So if you're ready, I can go ahead and share. Yep. So here's sort of the first chapter. So Optimus Walk has become more confident. And the first thing that I always want to know when I'm looking at this is like, okay, it's more confident, but how fast is it actually going? So I went ahead and I counted the steps. There's 8 steps over about 4.8 seconds. And using a guess of about 12 inches for the step size, I'm getting right around 1 mile per hour. So the speed hasn't increased from what we've seen. So I'm still hoping that there's going to be a speed increase. And what we see here in this section is that it's sped up 2x. So when it goes 2x, it almost looks to be a normal kind of walking gait. But the most important thing about confident, meaning that they can start navigating these spaces without having to have some sort of tether to prevent the bot from falling over, that they're more confident that's not going to, just suddenly lose its balance, which is why they had enough courage to bring out about a dozen of them amongst a crowd of people and have it walking around. And the only thing that caused it to fall over evidently was something to do with a purse. I'm not sure if it was a purse or a handbag. I think it was like snagged or something like that. But otherwise, that's showing a high degree of confidence that they wanted to go ahead and do that. Now, this next chapter here is showing it going through an autonomous workspace. And I want you to point out, Herbert, a little bit of what's going on behind the scenes right here. Okay. I'm just going to back up again on this chapter. And what do you see happening around here?
I mean, people are working. Just like
what are they doing? What?
I don't know.
Let's take a look.
Yeah, placing batteries. Oh yeah, they're placing batteries.
Look at
these are things that the bot could do.
Look at what the worker with the red hard hat is doing right now with his right hand. His left hand is kind of limp over there doing nothing. He's standing fixed and he's putting those things in the blue box. A little bit of irony there, okay? That
maybe it's an Easter egg. These are the things that Tesla bot will be able to replace.
Yes,
they're just showing it here.
The other thing you may notice in these scenes is that everyone is masked. The camera crew, everyone is masked. But go a step further, and I want you to also see what else is going on in the background. Is like, look at their shoes. Okay, look at their hair. They're wearing hairnets. They're also wearing the funny.
Oh, I see. Okay, so this shows you that now you don't need to have as much of it'll be clean environment.
This is a clean environment. It's not COVID restrictions, but the whole thing here is that everyone has to make sure that it's a clean room kind of environment, which is why
did you see that
hair nets and everything else.
Scott, it says you can now see unseen spaces. Can you explain that? Unseen spaces.
So in other words, it's never been here before.
Yeah.
And so now it's navigating an area it hasn't been. It can confidently move through it without bumping into things. So it can explore. So basically like FSD, you just like say go, and maybe it hasn't seen this particular road it's ever been on, but it knows what to do safe driving behavior. So it's the same thing as going through. And we're going to see in the next chapter how this is being done. So I want to use an analogy that we're all very familiar with, and that is navigation by stars. Okay. We're able to navigate by the stars for 2 reasons. One is that they're a fixed field. And second, the stars are actually very random. They're not, if they were a pattern of dots with the same separation between them, and you went outside and looked at the stars, you would have no idea where you are. So you actually need randomness in your scene to understand it. So what's happening is that their vision system is going through and is identifying these key points based on like intersections of edges and stuff like that, and is sort of identifying those dots. And those become constellations. And then all you have to do is identify. You don't need all those points to know where you are, but you want to at least be able to identify a couple of them. And the way you're able to identify this, the point that you think it is by looking at the pattern that's a part of it. It's part of a constellation. It's a part of Ursa Major. It's a part of Orion. It's a part of Capricorn, something like that. You look at that and you find a couple of key stars in there that you understand. And if you just have like 3, that's all you need to know to figure out exactly where you are in the world. If you have more than that, you get more precise data. Now, what happens is some star fields start to set and others rise, right? And we know there's continuity between all the stars out there. So as you start to lose some of the reference points you had, you get others to be able to tell you exactly where you are in this world. And meanwhile, of course, it's building up this star field, okay? It's just like the ancients, they started looking at the stars and writing it down on a piece of paper. And eventually they had the entire star field set up that we could figure out wherever we are on the planet. So this is what it's doing for navigation, because I think Milan pointed out indoors GPS doesn't work very well. Now, there are other things you can kind of use to create kind of a type of GPS environment inside, but this is a way of using pure vision to figure out what you're going on. The other thing you need to do is you need to identify those stars which are fixed, because we navigate by the stars, not by the wandering stars known as the planets. Because when the planets are moving around, they're never in the same location each night, and you kind of lose that reference. So you've got to figure out what you have fixed, what's not. And that's basically analogy of what's going on. If you have that information, and then if I create that network and another Optimus uploads that, it will be able to figure out where it is as well. So that's how they're building up everything else that's going on there. Yes.
Yeah, visual
So
cues. You can see the roof.
Right.
You can see the lines. It can recognize the doors. It can probably even recognize signs. And so now I know which room I am in. And then the other bots know which room they're in.
Yes. And they know their precise location by referencing these different green dots. And it's a little bit different than celestial navigation, because those points are often infinity. These, you're actually amongst them. So you have to kind of figure it out. But you've got continuity as you're moving around. I recognize this field over here, and I know it's going to distort a little bit, but it's okay.
This has to be the only company that can do this. I don't know of any other company that could do exactly what you just said, right? I mean, this is vision.
It's yeah, but it's basically photogrammetry techniques that go back 30 years or maybe more. The one ironic thing I want you to see here is that you do see that the cameraman is in here, and look at the backup camera that the cameraman has. It's an assistant, because the cameraman is walking back but not sure what they're walking into. And so
the bot won't have that problem.
Yeah, exactly. So you go around, and now you can start to create the environment you're in. So it no longer becomes an unseen environment. And from there, you're going to do what a lot of mobile robots have to do anyways, is like the systems like SLAM are trying to get a map in there to figure out what's the static and what's not static. So like the walls are static, the pillars are static, but you get dollies and other things that are moving around that you have to know, oh, it's not there now, it was there before, I can't use it as a reference. Or it's like, wait a minute, what's this thing here that wasn't there before? So you're going to have a dynamic environment that you constantly have to update and understand. And you may want to inform the fleet that, oh, guess what? This aisleway is blocked right now. Okay, don't go down here because a big forklift is going through, or very, very slowly. You're going to need to take a different route to get around. Okay, so this is the interesting thing, is it can navigate to the nearest charging station. Over here on the right, that's actually where it's working. That's a battery station it's going to return to. And you see very close to it, they've set up what looks like a type of Tesla charger. And you'll notice that there is this little lip that is sticking out here. This is the charging port that they have. They need to come over, and there's a mating area right on the back of the Optimus back that's able to go to. Now I'm just going to go back.
Yeah, go back.
A frame so we can see that. Yeah. Yes. Now
I do have so it's like a little corner area, and it's plugged in. So it's still a cord. It's still a plug, but not a cord and not wireless.
Right. And the other thing is what you have here is you've got a rear facing camera. So Optimus can see 360. So this is the backup camera for being able to do the parallel parking, if you want to think of that. And again, they're picking out reference points here on the charging port that they have to be able to go in there. Now, why do you think it's shaped the way it is?
Well, I don't know.
Why do you think it's sticking up like that? I think it's both a mechanical as well as an electrical connection. So they are able to probably hang on that, so that the Optimus can take a little bit of a rest, take the load off its feet. So in some ways, it's able to kind of go in there and then maybe suspend from it. So for some reason, there's
I want that.
It's really hanging on that. Right. Now, I think you've got the image. Do you want to share the blown up image that you get of that?
Okay. Yeah, I will.
You got that. I've got one I can share if not, but we can get a look at that, at what the port looks like to get some sort of idea.
That one?
Yeah. Okay. So it's a little bit grainy and a little bit fuzzy, but you can see what looks like electrical contacts, and it almost looks kind of like, not quite a USB port, but I think it's like a new standard probably for DC charging. And it looks like, your old thumb drives that you had there. You had those contacts, and it looks like it has two pairs of them, and probably some others for just communication reason and everything else. And it could be that, you want either redundancy in there, or because the amount of charge you're going to go through there. So it might be a new standard that they're coming up with here to be able to do the charging. So it almost looks, again, it'll look like your old USB or your old thumb drives that had kind of contacts that looked a little bit like that.
Whoa.
Okay,
Quick,
so
change
you're
that.
back. You're back. Yeah, yeah. We're back to my screen. Okay,
There you go.
so it's sort of interesting how they've designed their own thing, because we were all assuming, oh, they're just going to have some sort of standard plug in there or something like that. And also we can say it's not inductive. We know the RoboCab
Right.
is going to be. You don't want to do it with Optimus, because then it means the hardware on Optimus is going to be heavier. You're adding mass that you don't want to have. So you want to offload as much of that to somewhere else.
Putting it in the back, though, then it's harder for it to be inductive, because normally you'd want to put it on the foot or something that's
on the foot or something like that. But even there, you could do it, but that means you need to add some components that add mass. And this is the most efficient.
You might do both.
Yeah,
right? You can, if you want faster power, you go in the back. If you want to just stand there and take really slow trickle power, then okay, go ahead.
Yeah, that might be possible. But again, when you're doing that, requires putting things in the feet, requires the wiring and everything else that goes around there. So if you're trying to reduce the mass, that might be sufficient. But again, we can see from this, we can't quite see where the charging is in this shot, but you can tell from the previous one that it's very close by. So when Optimus needs a boost, it just walks over there, because you can put them anywhere. You've got electricity throughout the building. It's probably very easy to go ahead and mount that and put it in there. So it's, and as you can see, it's a very small infrastructure. It's not like there's a huge footprint involved in it. And it can be right next to the coat racks where everyone else, is like hanging their stuff. They're probably going to put a sign in here, "Do not hang coat on here." Okay,
somebody said that. Yeah. Looks like a hanger.
Yeah, exactly. Like in the hotels where they have the sprinkler systems, like, do not put coat hangers on this thing. Okay, so this is an interesting update, because we've seen this before where Optimus came in and it was just packing in there, and again, the operation looks exactly the same as the operator that was doing it, which is maybe is where the learned behavior came from. But the big question was, well, what happens to this thing when we're all done with it? Because it's just going on a table. I'm surprised it's not on a dolly. That would be easier to push around. But at some point, it has to be lifted up and moved around. And again, they're being able to then identify the object, get all the key reference points to sort of understand the nature of it. And now it's picking it up. And I was going to try to figure out how heavy it was, but they did it for me. 11 kilograms, which is probably around 25 pounds, something like that, which is a significant weight. Now look at how it grabs it. And I want
can you pause there for a second?
Yep.
Pause there for a second, because we've heard other robot companies say 50 pounds is the max that they'd like to be able to shoot for. This doesn't tell us anything at this point. It can do 25 pounds, but we don't know if it's.
And it might be able to do a bit more than that, but we know you can do that. And the reason why 50 is that's kind of like a cutoff that OSHA has. That's the reason why your check-in bags are limited to 50 pounds.
Okay.
And why you have to pay extra to go a little bit more, because they really don't want workers to repetitively having to lift objects heavier than 50 pounds. So that's part of the reason for that cutoff.
It does say here, it can now also pick up significant payloads, such as this 25-pound battery tray. So they're not saying that this is the max. They're just saying
that's not the max. Now, I want you to look at that. I want you to imagine a tray of that shape with those tiny little lips around there.
Yeah.
Your hand coming around there and your fingers and you picking it up. And I want you to imagine this grip. Look at that right now. Look at how the fingertips are holding onto that.
The fingertips carrying it.
Okay. For me, that I would not live. No. I would not be confident personally myself carrying that tray with my fingertips being able to apply the amount of force you would need to hold it in there. I would try to get my hands underneath the tray a bit more. So that means the grip strength on those fingers is pretty strong to be able to do that. So first of all, both arms are having to push together. All right. Remember, your arms are trying to be pushed away from that. And then your fingertips are holding on it. And there's also a lot of torque that you're feeling on your wrists. So I want you to imagine doing that. You can feel how much your wrist is having to fight, how much your shoulders are having to push in. And then your fingers themselves, your fingers are wanting to open up from that weight. And you're holding it in there. So that means locked in. And then that's one thing to hold that statically. Now I need to walk without that thing slipping out of my hand.
Pause for a second. So just to again clarify, many bot companies have decided to do pick and place, and they decided to do these special grippers and then sometimes will actually require that the bin is created a special way, so that the grippers can grab the special thing. The whole point of this idea of let's make it humanoid as close as possible. We're going to have the 22 degrees of freedom. Not that this is the 22 degree freedom hand yet; it's probably the 11. But the fact that you have these things, and if it's powerful enough, it can do any tray. It's not especially this one.
Yes,
It's
yes,
definitely
that's
not.
the idea.
It's not only is this not designed, it's actually poorly designed. I can't carry this thing. This is not good for me.
I mean, the way I would carry it is I would slide it like halfway
Right.
off the table,
Grab the
so I could
bottoms.
get my hands underneath it and
Yeah.
then pick it up, because I don't have enough confidence in my grip
Yeah.
strength to be able to do it. So
Yeah.
I'm looking at it, I was like, oh, okay. I think you actually might want to, just for safety reasons and overall security. But looking at that, I was like, and then the most impressive thing is the finger strength.
Yeah.
You know, I'm expecting, because remember we've talked about the parallel kinematic, and you know how the pitch movement of the wrist works. This is an example where you're probably getting a lot of load on the pitch of your wrist right now to resist that load. So that means, you know, you're putting those things in there. Even the elbow itself, it's got to kind of keep itself locked in there. And then your fingertips, that's a lot of strength that's kind of going on there to be able to successfully carry that load with such a small lip. The margin of error there is really small. That could very easily slip out. So if the hands just kind of separate a little bit, all I have to do is like lose the relative position by half an inch, and that thing drops. And then, of course, we see right there, just go back there a little bit on that, is the approach is, you know, there's still a little bit of stutter stepping coming in, which I'm sure they're working on, that all of them sort of have that when you make that final move. So that's something they're going to want to clean up to make it a little bit quicker, so you don't have the final, but it's not too bad there.
It's not terrible.
It's reasonable with there.
Somebody pointed out here, Scott, that this no longer, this scene here, walking up the stairs, they don't say autonomous anymore. Teleoperating.
Okay. The autonomous stuff that I've seen. Oh, okay. So yes. So maybe they're showing autonomous there, and then autonomous 2X, and then, okay, that's possible. So it is now venturing, but I would think that I don't think they would be teleoperating. It'd be interesting. I mean, they must have some sort of learned behavior.
I mean, they see the label pops
up
back up at the top right, autonomous.
Yes. So, but still, I don't know how you would necessarily telerobotically have it walk up the stairs. Let me kind of get back to the steps.
Let's watch it. Have we ever seen any? Yeah, we have seen some other bots go up and down stairs. So it's not.
Yes.
It's not. Unless they said it was autonomous, unless it's the right speed, which they don't say what speed it's in. Maybe that's one reason. Maybe
it may not be autonomous, but there's a lot of there's not someone teleoperating this thing. There's got to be something for the balance control and everything else. That is not something I would just say I'll have the teleoperator do that.
I love the design of the shins there, the calves. They look just like calves.
Oh yeah.
They designed to make it look like human.
Well sculpted. And if you kind of look right up here, you can kind of see where the charge port comes in.
Yeah.
So there's like a little lip right there that's where it goes in.
Okay.
So it's part of the reason watch your step. That's kind of
okay. This is the thing that kills me. I mean, they could have made everything autonomous. If this was shown, they could have just had one bot doing it. My God. If this was shown to the Wii robot, look, it waved at you. Yes. It can react to unsafe behavior. So it's knowing, does it recognize that this guy here is putting his, fist, he wants a fist bump. Does it recognize that? So he's probably seen it before. He's been taught it before. Now he knows. And
you see, he's scolding him right there. You see the little finger wag going on up there. They'll say, "This is unsafe. I'm not allowed to do that." So please stand back. So that's what's
react to unsafe behaviors. Okay, so it's not the fist bump. It's just more like, hey.
Well, it's partly the fist bump, but maybe he's getting too close.
Yes.
Just like I'm not allowed to do that. I'm not allowed to touch you because that's considered an unsafe behavior. So probably a little bit of scolding, a little bit of warning, and now again reading body language. Yes, pointing to it. So the idea is that you use a hand to point out the different items, so it knows it's got two different sets of items there. It can pick one of them, hand them on over. And there is no verbalization going on there because we didn't, there is no Grok integration yet that we're aware of, but instead the LLM is doing it. Now, I want to go back to FSD. We all remember the earlier versions of FSD with VRUs or, basically vulnerable road users, meaning cyclists, pedestrians, etc., that usually when FSD was driving at that point, if there was a pedestrian like anywhere near the road, it would freak out and slow down, even though we as humans could tell that person was not a threat or a danger because we could read their body language and get an idea of what it was doing. Eventually, FSD got better and better at that, and that now it like can really tell when a pedestrian is probably going to walk in front of the vehicle versus not. Almost by it's kind of learned to read the intent of what people are doing walking down the street. So I suspect that that same kind of learned behavior, that same capability, is able to be used here to intuit what the intent is of the person attempting to interact with Optimus. So in this case, it's very straightforward. That one interaction was, that's unsafe. I know you want to do a fist bump. I'm there with you, buddy, but my training does not allow me to do that. However, I can hand up an item. And now you see the human's not quite so sure. It's like, am I allowed to go in there and grab it from him? Because he was just scolded before.
I tell you, Scott, when we were at the event and we had a teleoperated bot just like this, handing out items to people just like this. And I walked up and that bot handed me an item. And I knew it was teleoperated. But just the way that the bot was able to hand it to me, I grabbed it. You know how when you're handing an object, it's like, which part do you grab? Which part do they hold? And then that exchange where he let go when I grabbed it.
Yes.
Now, of course, it was teleoperated. The guy was doing it, but it was just that feeling for me was, oh my God.
Yeah.
I just
and the other thing that's
interacted with a
here
bot.
Is look at with the bottle for a second here. So the bottle comes on up here. Optimus is holding it.
This is autonomous.
Okay. The human comes in.
Yeah.
And look. It like releases it. It's almost like an instant grab there. I'm surprised that the bottle didn't get dropped.
Yeah,
but it could be.
It was 2x. It was 2x, but still.
It's 2x a little bit there, but Optimus immediately releases because it doesn't want that interaction with the human. If it holds on to it and the human pulls too hard with on the bottle, it's possible Optimus can lose balance or something like that. So it's very interesting how it knew like the instant that it was safe to open up the hands. And even though it was 2x, the fingers seem to open up reasonably quickly there. So when they release the tension on those tendons, bam, it
How does it know
to get out of the way?
Can you just go back with a potato chip here? Because it let go when he realized that the human already got it. Like you don't want it to let go before the guy has grabbed it. Like if I'm just about to grab it and then he lets go, that's not good.
So let's look at this right here. So we're going to see comes up. And then it seems like the fingers are almost already opening. So the bottle drops a little bit. And so it must be partly vision based. It might have made the decision, I think the person has it. So it's pretty lucky that he actually was able to hold on to it as opposed to feeling the force. Because that's the other way, is that if someone else grabs it, you should be able to feel the interactive force between the two. Now,
that is
with
crazy.
Potato chips, yes.
That is so hard of a skill to know. Humans make mistakes all the time when you're
coming on over here.
Yeah.
And already, see, is it releasing? No, helping it get down there. Now it's kind of releasing. So it may be feeling a little bit of a tug at that point. Saying, okay, it's safe to pop the hand open.
I think it's vision, like you said. It can see that the hands, the human's hands are close enough. It's already kind of handed.
Yeah, I think it's a combination of vision and probably also feeling a little bit of force.
Yeah. Well, that's the whole thing, right? Just the more times you do this, the more, like if you do this 1,000 times, handing something, it'll figure this out. These new skills are all learned by single neural net.
And let's,
which means
that's too quick for us to be able to see because it's 10x at this point. So it's kind of hard. And see right there, it almost seemed like the same thing is that.
No, I love the tilt. I love the tilt. Look at that tilt. That like tiny little gestures like that. The tilt. It learned this.
And I think it's a little bit different for each one of them. So that one was like more vertical up.
Well, that's because the guy was further away, maybe.
Yeah, depending on the position where the person is, where the hand is coming, what they want next.
What happened there? Did he drop it? Okay.
No. I'm not. Oh, you mean the person?
Yeah. I got to rewatch that. Okay. Can we? Oh my God. I'm going to play this again from the beginning, just because I think there's new people have come in and we just want to watch it. So let's again, I'll just speak. I'll be the only one speaking so that we don't interrupt it too much. Look at those shoes. unseen spaces, avoiding people and obstacles. Yeah, you explain the visual cues. It knows which room it's in. Okay, every bot is sharing it with every other bot. Now they know, they map the navigation of the room. Okay, they could charge themselves, and this is the docking station. It's this thing. It is a touch point, and then they connect, and then they insert, or at least touch. You can do these kind of maneuvers, but it can also pick up to 25 pounds. At least it says this one is 25, but it can maybe more. Just using its fingers, like you said, placing it wherever it needs to go. Walking upstairs, but it doesn't say autonomous, so we don't know, but it can still do it now. So that's, and then this part here, just crazy. It can interact with people, so it does visually, and it can recognize what you're asking for by just pointing. It can grab different kind of items. It's all autonomous. This is all autonomous. Just this alone could be billions and billions of dollars.
Oh yeah, yeah. So
you don't have to pay a human.
A lot of restaurants and stuff like that to be able to serve those different items without a doubt. Now, there is one thing missing in those Optimus versus the ones that we actually saw at We Robot. Do you know what's missing?
Well, I don't know.
Look at one of the images just of anyone that there's something missing. It's subtle.
Let me see. Well,
look around the shoulder area. Look around the shoulder.
Okay.
What's not there? I
don't know.
The number.
Oh,
remember? They all were wearing,
right,
their
numbers.
Their numbers.
Yeah.
And none of them in here have it. So
what do you think? Why does that? Because it. Some people said they saw a number as high as 40. What did you say? 41, 43?
43. I saw 43. Yep.
Okay. But yeah, why is that? Why is this one not having those numbers?
I don't know. It's rather interesting. Probably out in the field, they decided they needed to be able to identify each of them that was walking around. So they definitely put a number on there. But for some reason, that's not the case in the factory, or at least what they're doing here.
Interesting.
And maybe part of it is just to disguise the actual number that they have, because maybe that is Optimus, 5,362
instead of a robot with wheels. And we've made a lot of progress with Optimus. And as you can see, we started up with someone in a robot suit, sort of down, and then we've progressed dramatically year after year. So if you extrapolate this, you're really going to have something spectacular, something that anyone could own. So you could have your own personal R2-D2 C-3PO. But fundamentally, at scale, the Optimus robot, you should be able to buy an Optimus robot for, I think, probably $20,000 to $30,000 long term. So, and what can it do? It'll basically do anything you want. So it can be a teacher, babysit your kids. It can walk your dog, mow your lawn, get the groceries, just be your friend, serve drinks. Whatever you can think of, it will do. And yeah, it's going to be awesome. I think this will be the biggest product ever of any kind. Yeah. Because I think everyone, of the 8 billion people of Earth, I think everyone's going to want their Optimus buddy. And there's going to be maybe two, and then they'll be producing products and services. I predict, actually, provided we address risks of digital superintelligence, 80% probability of a good outcome. Look on the bright side. The cup is 80% full. The cost of products and services will decline dramatically. And basically, anyone will be able to have any products and services they want. One of the things we wanted to show tonight was that Optimus is not a canned video. It's not walled off. The Optimus robots will walk among you. Please be nice to the Optimus robots. So you'll be able to walk right up to them, and they'll serve drinks at the bar.
Okay, so one thing I want you to notice is that, you know, the t-shirt that Elon is wearing is the same as it's the Optimus t-shirt. He has worn that more often in public than I think any other t-shirt, including I think at like the IFT4 launch. There was something like that when he was interviewed by Ellie and Tim. It's like, oh, he's wearing the Optimus t-shirt. He's not wearing a SpaceX t-shirt. He could have been wearing the We Robot t-shirt like everyone else, but he chose that. I think one of the earnings calls, he was wearing that, and it's rather interesting that that's his go-to. I'm kind of wearing it, thinking that it's almost time to retire this because it's the old hands, it's the current generation hands, and very soon the new one's going to come. So it's like, well, we can't really wear this anymore. But that's a rather interesting statement that he could have been wearing, like, you know, the Cybercab t-shirt or something like that. But nope, he's doing that. So that seems to be a really big focus of him, wanting to see that the potential that Optimus has.
Yeah. This, so again, the criticism they had was they had 20 bots at this event with 2,000 people, right? You and I were there. We interacted with these bots. Many of them were freely out there walking. Some of them were behind these counters handing it off.
Yes.
What people don't understand is that, and Milan Kovac pointed this out, I think, was that every time, or one of the Ashish that I talked to that engineer, every time that is handing it out like that, that's a training.
And more than likely, I would not say that this was telerobotically controlled. It may have been more like supervised. So the bot was doing everything.
Believe that now.
The verbal interaction, the verbal interaction, because Grok wasn't in there, was with the teleoperator. What do you want and everything else, and indicating it. And they were probably supervising, making sure the bot was performing correctly. And if something was going wrong, ready to like hit the stop button on that, because of the concern of such a large forum of people being there. Many of them probably drunk, some of them swinging handbags and making sure Optimus is able to remain safe, and that the public at large out there is in a safe situation. So I have a feeling it was more like FSD supervised, as opposed to, you know, someone who's really driving the whole thing. So more and more, I begin to understand that it's like they were doing that same thing. It's just someone was there with a remote e-stop button.
And this explains that the walking at the event was not teleoperated. It was
no. I think it's like FSD is that they may have been giving like a goal. We want you to go here. But now going there is not a straight line. Going there is like there's hazards and obstacles. There's other optimi walking around me, just like FSD. You know, you say you want to go someplace, and it's driving the same road each time, but it's driving that road differently each time, depending upon the conditions and other vehicles and everything else along the way.
Jesus.
So it's more or less, again, I would go less that it was telerobotic, because I have not seen anyone really do walking telerobotically. The arms telerobotically is something else, but walking requires balance and stuff like that. And if you are mimicking the motion of my legs, there's a good chance
you're not physically there.
Because my body mass and my center of gravity and everything is very different than the bot. So if you're trying to imitate my walking, you're going to fall over. Now, maybe you can say, I'm going to use it as an idea of a destination that I want to go around. But then you have to have a twin of both environments, right? That I'm navigating the exact same environment that you are for it to figure out. So it's more or less that I want you to go forward, I want you to go left or right, or I want you to go over to that fountain over there. Okay. Yeah. And then look at that fountain. And just like FSD, you're going to see a pathway that allows you to get there. And you're going to try to navigate the most favorable pathway. And then if people are getting in your way and other optimi are getting in the way, you stop and then go around them.
That was so cool, watching the bots all over the place. You turn around, there's another bot there. They're all walking, they're all dancing, they're all moving around. And now we know that some of it was actually autonomous. So I'm going to just play another thing that they released. Tesla released this video, and it shows how Tesla cars and robots share a lot of things. Same batteries, computers, and cameras. Those are the same batteries. Yeah. So that's what they released.
So the same battery. Now we're going to be a bit careful with this video. I don't think it's necessarily accurate as far as the battery count. So if you count that up, as the number of
Right.
batteries, depending on what cells they are. Are they 4680s? We can't tell if they're 4680s. It's questionable for the Cybercab. I know it's wrong for Optimus because Optimus is 2170s. We've been able to confirm that again and again from various images. And also the battery count that they showed in that animation is wrong. They're showing 10 by 9 and it's 14 by 9.
Scott.
And they're 2170. So the thing is I don't want people, because a lot of people are probably doing that and jumping to conclusions. What it basically means is that, look, Tesla, we make batteries, and we're making 21
cameras,
we're making 46
and a computer.
Cameras. We're making battery management systems. We've got all that stuff. So it'll probably be very close. So again, the FSD chip that's inside the Cybercab is the same thing that's going in there. The battery management module is probably going to be very, very similar. This is like I think it's like the battery pack is 52 volts nominal, which basically means it's a 48 volt architecture. Okay. That's what they're using. So again, the same kind of things that are going on in here in their other vehicles are able to leverage and go in there. The actuators, I think the number of actuators in the Model 3 is more than in the Optimus. And some of the actuators there are very similar. And I think someone pointed out that, an example of componentry that they reuse, like the Robovan, many of the components in there are already coming off of the Tesla production line that are used in other things. So they're reusing many of the same components that they already have. They're not having to ramp up something else for it. And also on the Cybercab, the door opening on that thing, the actuator for that is the same actuator that's used to open the lift gate on the Model 3. So it's like, okay, they are able to scale and come up with these things because they're not necessarily reinventing the wheel all the time. They're taking existing technology they have and leveraging that capability. And it's going to take me a long time to properly pronounce it. Robovan.
It's Robovan. Don't call it Robo. He was making
everyone is saying Robovan. That's actually, I think, how Elon called it. That's how
this is me.
Franz
and
called it.
This guy that I happen to be with. We're checking out the Cybercab. Look at those. I think the butterfly wings are just temporary. I don't imagine that will be the final production.
It's going to be similar. It's not going to be exactly that because there are a few things that were pointed out. And again, they're already, for this prototype, they're using existing componentry, and maybe they have to come up with a slightly different actuator. So you'll notice that when that opens up, it really came out wide, a lot wider than expected. The expectation is they're going to change that so it's not so wide. It's going to go more vertically.
So the hands here still have the cables coming out, and we now know that this new hand is going to be done, right? So these hands are amazing. So I'm going to show you guys what the hands look like. I think this is not as nice of a view, this one, but
now, how close were you able to get to that hand?
The funny thing is, I never saw where the friggin' hand was. I'm so upset at myself.
But it was in the VIP area, so I could not get that close. But I could see it off on the distance. So these are really now what I assume it's about the same size as a normal hand. I'm not sure if it's a little bit bigger or not. It's going to have different routing, and I put out a post yesterday explaining the slight modifications they made to the wrist mechanism, because the current wrist mechanism, you see that there's those two very large black actuators on the wrist that are kind of sticking out. They now need to be integrated more tightly in there, and they can't move around. So right now, those actuators are actually moving around as the wrist moves. And they've come up with a slightly different design. They're going for basically what would be a 3-bar mechanism to a 4-bar type of mechanism that allows the servo to remain stationary. And they added an extra link in there that's really hard to see because it's kind of in the backside. But they made that change to make it a lot sleeker so they can fit everything in there. And I assume that when they're done, they're going to have some sort of skin around the outside, because you have all these tendons that are moving around and sometimes kind of bulging out in different ways. So when they're done, it will be packaged up and you won't see any cabling or anything like that. And I'm sure they may have some covering of some sort on the hand itself. So this is still early prototype, may not even be the current version. It may have been like a second or third version of the hand, and whatever the version they have right now is a little bit more. And people have probably heard me protest many times looking at that thing, that is not a 22 degree of freedom hand. It's 23. unless there's something else going on there that I don't quite understand, because they added a crease in the palm. So there's the palm is actually able to, around the pinky, able to close in a little bit there, which is why I'm counting 23 based on that, unless they took away a degree of freedom somewhere else. But still, it's a lot of degrees of freedom, but it's not so much the degrees of freedom that are impressive. It's the number of actuators. Because if you start counting all those tendons, each one of those tendons has to have an actuator on the other end. So it's not like 3 tendons are going to be sharing the same actuator. They are going down to their own little actuator to be able to be pushed and pulled. So that means they probably have about 16 actuators. That's an estimate. Some other people looked at it and come to, almost counted the same number. But then again, I counted the batteries in that animation, and someone else came up with a different number. We were close. A little bit of disagreement. So it's kind of hard from those images to precisely know, except to say it's a big number.
Yeah, he's saying it's 22.
They all say it's 22, but it's really hard when you look at it to figure out how they are doing that counting at 22. And it could be that there's some other, are they counting the wrist axes in there? My feeling is that they're counting the pitch and the yaw in that 22 degree freedom hand. It sort of makes sense that way.
But I'm going to pause it right here, because that is the one thing that's we know is going to change. It's right here. That forearm, that hand,
that whole
wrist,
thing is changing. Everything.
That's why it looks. That's the only part of the bot that looks clunky. It's got these wires sticking out, cables sticking out, right? Mm-hmm. And this whole part just
and those big actuators that are sitting there, So you
that's all going to be. You can see the gorgeousness of that new hand. Boy, this is mind blowing. Honestly, right? I mean, this is way more than I expected for sure. This is autonomous, right? Walking around, grabbing things, interacting with humans, recognizing gestures, being able to actually recognize a room, mapping the room autonomously, unseen spaces, just gestures, and then this whole part right here, right? Being able to grab and give somebody an item autonomously just by, I point. It kind of knows. They taught it, of course, but if it can do this, the bag of chips blows my mind. You know how hard it is to grab a bag of chips?
Right. Now,
that is not easy. It's not a hard thing, right, Scott? It's not like this hard, object that you can grab.
Yes, it's a flexible object that sometimes is a lot harder for a robot to figure out how to pick up than something that is rigid. The other thing with reading the gestures is that would mean it's just a small step from there to what would be more like this monkey see, monkey do. So everyone is assuming that you're going to need teleoperation to be able to teach Optimus to do whatever is the job that you want. It's like, no, those are the early days. This is what Tesla has to do to get the foundation models and everything built up that understand certain things. And then take a look at the chin and the lighting on the. Oh yeah. So it's going to come on there and let you know that's in the charging state.
Oh, that's so beautiful.
Yep.
See that? So it's white and red. Is that what's going on? Oh, red means a battery.
The battery is probably low. So low state of charge, so it's red. And then green probably means it's in operation.
This is white. White means it's fine and it's operating.
Yes.
That is so beautiful. Oh my God. Do you see that?
So you will have that. Yep. Absolutely.
Why do they even have the word Tesla on it? You don't need this. Cybercab doesn't have it. Cybertruck doesn't have the Tesla logo. I guess they want to differentiate themselves from all the other companies that are going to try to copy them, exactly the same look and feel that you want to say, this is the Tesla one.
Now, the other thing I noticed was very natural was the movement of the head. So when you were interacting with
right
Optimus,
there, it's looking down. It pointed, it looked down. So there, it looked a little bit of a head, neck. There.
That movement will get better. Yes. So when under the teleoperation control, the head movement was very natural. So we know it has the capability to move in a very natural way that makes you very comfortable being around it, interacting with it. The other step here is that, again, with it understanding your intent, eventually you will teach it new tasks just by showing it what you want to do. So it will look at you, see what you're doing, and then say, okay, I will do the same thing that you just showed me. I now understand what you want to do. people who start purchasing Optimus to be used is not going to come with telerobotic control because it won't be needed.
Take a look at the bottom right here. So that's the bot, and it's got the blue pathway, just like FSD. It knows where it's trying to go, and then it can say, "Hey, there's a green thing here. Maybe it recognizes that's a human. That's a human. That's a person."
Okay, so basically, be very careful around that person to make sure you don't accidentally
it's
bump
just
into
like
them.
FSD. This is what full self-driving in the cars does. The other thing I think that when you were asking me this question earlier, this is a live factory environment. This is a factory. This is like they're doing work. This is what it is. This is the
battery plant. Yep.
Lab that they're replicating.
Cato Road. Yes.
Yeah. That's why they're all wearing helmets, or what do you call these things? Hard hats and hairnets and masks and shoe covers, because they're working. This is what it is.
Yes, and it has to be a clean room environment. So that's why they're wearing it. And again, they have picked Cato Road at first because probably the number of employees that go in and out of there are a much smaller number compared to what's happening in Fremont production, which means it's a lot easier to keep a lid on what's going on as opposed to, because the old adage is that the chances of a secret going out is proportional to the square of the number of people who know it. So if you have more people looking at this, you're going to find out a bit more. And Tesla has been very good at making sure no one leaks this information. So I've really been surprised we haven't heard more leaks about this up till now. And we're only seeing at this point. It doesn't mean they're not doing operations somewhere else. And it may be that they are, but at this point, they've chosen not to reveal that, at least publicly. But we can see it is able to perform some sort of task already here in the battery plant. And it's Herbert, I think you're muted. There we go.
Yeah, there we go. You can see on the right there, its vision of what it's looking at from the front, from its front view. And he sees the table and says, "I'm going to put it there." There's a person on the far right there. There's a camera because they're measuring this right now. And I don't know if that putting on that table, I think that seems to be doesn't seem to be like normal work.
Yeah, well, at some point that tray's going to disappear from there and go somewhere else, so you can load more batteries off of there. And I've always thought you would have put something like that on a dolly, or you'd have a conveyor system to get it out of there. But it may be that they have other operations that are needed. Yes.
You have been saying this. I just want to point to people out. Scott is a 2-time robotics founder, and he does the industrial robot. So you see on the right there, the top right, you can see that industrial robot behind cages. And what Scott's been saying is that when you actually have robots doing the work that the humans have, you don't need to have these cages anymore. It opens it up. Correct. And you can have bots working right along with these guys because they're perfectly timed with each other. And that just changes your environment if you wanted to. Now, you don't need to. That's the whole point, that humans can do this. But
if you go to the very beginning, so that is a Fennec robot over there. And again, it needs to be in a cage because that moves very fast. It's very heavy. And if you get hit by it, you're going to be injured by it, definitely. If we go back to the very beginning, we did see Optimus walk past that cage.
Oh, yeah.
So we see that right there. And again, you can see all the floor space. It's kind of taken up by the fact that you have to cage it off. And they have to do all kinds of ridiculous things. So you have, if you just pause it for a second, you'll see there's a door that goes in there. You need to do this lockout kind of procedure to open up the door to make sure the robot is stopped and everything else. You'll see there's a conveyor system that comes into that thing. They have to go and make sure people don't do silly things like get on the conveyor system to climb into the into the active cell. So usually they'll have other things to be able to. So the safeguards you have to put up there gets absolutely ridiculous to make sure people don't accidentally get in there. Now, as Optimus is walking around, he does go past a person doing the exact same operation that Optimus is doing in another area. Right there. Optimus could be doing that right there. You could take that person out and could be doing the exact same thing without a cage. That's the whole idea, is if they say, oh, we want to automate what that person is doing right now with an industrial robot, suddenly it becomes very complicated. But in this case, you could just say,
they can't do these two guys. I think they're using a computer or something.
Yeah, they're doing something else. But we can see that Optimus is already doing the actual task that person's doing and could do it right there on location without a problem. Now, we're not sure about the overall certification and what they kind of had to go through, making sure that they were doing it, that it was safe, that there may be some restrictions like, okay, we know the Optimus bot can do that, but we still have a little bit of concerns that you may need to make sure there's some light safety fencing or something like that for now. But eventually it will just go in as a replacement, and either a person can be doing it or Optimus can do it, and they can be switching on and off without you needing to redesign the cell, redesigning the end of arm tooling, redesigning the safety protocols or anything else.
Yeah. This is crazy. Okay. So basically Tesla just dropped a brand new video showing off the Tesla bot doing all sorts of things. We just spent the last 55 minutes here going through every single frame. It is an amazing. This is beyond my expectations of what Tesla is able to do. Everybody assumed right after we saw the bots at the We Robot that it was still teleoperated. Now, this thing can do the grab and hold of different items. It can recognize, and what you saw there was the bot can actually map out an environment just like the cars can. They can see what's there. They can see what's human. They can interact with it. So if it can do the handhold and grab that, all the other things you just saw, we're grabbing the pail and putting it in there. That doesn't seem so far away anymore. Now, the whole point of what Tesla's doing is they've got at least 40. We know at least 43 because we've seen in the We Robot event, they had the numbers on them, and one of them had 43. So let's say there's 100 this year. Let's say there's 1,000 next year, and they just showed you that it can do work now in the actual factory. He's saying 1,000 to 2,000 next year. So once the hand, that new third generation hand is finalized, they're going to be off and running. The more bots they have, they showed you that each bot will teach the other bot both the location, but the tasks, and they just feed it info. One of the Tesla bot engineers was saying the more bots that was actually at the We Robot interacting, all those videos, all those training is fed into this one neural net, and this one neural net is learning. This is huge, Scott. Huge. Okay, just quick final thoughts.
Yeah. So as far as like next year and the different timelines, my understanding is that the Gen 3 bot is the one that they're going to scale. So you may not see 1,000 of the Gen 2 because it's sort of the end of the line as far as the evolution of that platform. We know the hand is changing. We don't know how much else is changing, whether it's a radical change or just some tweaks to it. And it should be finalized by the end of this year, which means starting next year, they'll be able to ramp it up. And they're also designing it more to be easier to build these units. So, but it's not clear that's the one that they're really going to ramp up eventually. So enough is to make sure that they can get maybe a couple thousand next year to use within the Tesla factories. And then at the end of next year, starting in 2026, they will start scaling, which might be sort of like the Gen 4 version, which just means they're going to take the Gen 3, take the experiences that they've learned from it, make some modifications, figure out how they can scale it up, and then be ready to go. Something that was pointed out by numerous people is there were something like 150 CEOs of other companies at the We Robot event that had kind of like a private event going along with it. So they may have been shown like this video already, or maybe even other videos of what's going on. One of them evidently, and I think it's been confirmed by multiple sources, was the CEO of Stellantis was there. Mm-hmm. And so you have to wonder, is like, hey, why was the CEO of Stellantis there? Was it because they want to put FSD in their cars, or is it because they're also thinking about the bots? And
I love it.
I think for most of the companies, things are going to be business decisions, and you can't run a business on emotion. So you can't say, we don't want to buy this from our arch rival. Okay. The question is like, is this technology, even though it's coming from someone that is a competitor of ours, going to make us more competitive or less competitive? That's it. That's the decision you have to make as a CEO. And all the emotion has to be a way of like, well, we don't want to help Tesla. It's like, look, they're already giving them ZEV credits for years and years now.
No, they can't help it.
Getting nothing for that. But at least now, if you buy the Optimus, you will get something for it. And that is your production costs will go down.
Yeah, they need the opposite. Okay, Scott, one last question for you. How many bots does Tesla have?
Right now, I'd say in the order of 100. 7,043,000. Oh, okay. You
gotcha.
Trick question. I should have known.
I'm right, Scott.
Wait a minute. There's that many Teslas out there?
Well, they're going to hit 7 million by the end of this year.
by the end of this year that they
Yeah.
produce. Okay, and then I assume that what percentage of those are no longer functioning?
I don't know.
I don't know,
All right.
10% or something like that. But
Thank you,
but
everybody.
yeah,
Yeah. See you soon. Bye-bye.
Bye.